Hi class, we're Team 12. I'm Ali.
I'm Ida.
I'm Florence.
Today we're presenting our inventory counting product, SmartInv. In spite of the modern inventory system, retail stores still hire people to do hands-on inventory counting. SmartInv takes advantage of the inventory tool Sigma to simulate real-time manual counting process. With SmartInv, retail store managers will be able to make efficient and cost-effective decisions in inventory counting management. We will talk about the current inventory counting problems, SmartInv's target client, and the objectives of the product. We'll also go over the simplified model, live demonstration of the product, the output reports, and unique features. Our target client is retail stores with SKU and non-SKU products. Retail store managers hire workers to do inventory counting during store closing hours. The way things are done without SmartInv is that the manager hires inventory counting workers based on past statistical data and experience. This method is not accurate and efficient since it fails to factor in changes such as expansion of stores, changes in labor costs, turnover rates, and available inventory counting hours for stores. Such method is likely to lead to inability to utilize available resources, failure to complete inventory counting on time, and waste of labor costs. Therefore, the invention of SmartInv provides such an effective and efficient tool for improving inventory counting process.
The objectives of SmartInv include reducing costs, utilizing available resources, improving service level, maintaining accurate inventory records, determining ideal worker size, anticipating workers' turnover rate, absentee rate, and productivity level, differentiating among different types of inventory. Now, I'll walk you through a quick overview of our model. The simplified simulation starts with the day node, incrementing the number of days and determine whether the day is a weekday or a weekend. After this is determined, daily inventory accumulate based on our random processes conditioning on SKU or a non-SKU worker type. After this, we use beta distributions to factor in turnover rates and turnover counts. Once workers got turnover, the training process is immediately started, and after a specified number of training days, those newly trained workers are put into the pool of contracted workers. After this, we use similar processes to calculate absence rate based on the random processes. The next stage we will go into is our counting and calculation processes. We use the daily inventory level to calculate inventory counting time. Last, we calculate our labor costs based on our specified daily labor wage. Furthermore, penalty costs will be added to our daily labor costs if the daily processing time exceeds the number of available regular counting hours. The simulation will stop once the number of days exceeds the user's specified number of days. Our simulation product allows the manager to create their customized inputs to the simulation. Once we started with our simulation, the manager could manually key in their input values. I'll show you how users could input those values. Time, such as number of days, weekday hours, weekend hours, and the prefill section of wage, worker count, time to train, inventory size based on weekdays and weekends, counting rate based on SKU worker and non-SKU worker, turnover rate, and absence rate. They're based on the beta distribution. Finally, when we click on the run simulation, outputs for 10 runs of simulation will be generated. It will usually be generated less than 10 seconds.
Since we input 30 for the simulation days, the report will generate simulation outputs for 30 days. The output include graphs of daily labor costs, daily contracted worker counts, daily turnover counts, and daily attendance counts. Users could also obtain a graph comparing total costs for 10 simulations using different sets of random seeds. SmartInv allows users to do sensitivity analysis in two ways. First, each simulation is subjected to a different set of random seeds, which are used in the generation of normal and beta distributions in the model. So a different set of random seeds will generate different sets of outputs. The simulation has run for 10 times, and these are results using 10 different sets of random seeds. The user could then do sensitivity analysis by inputting different values to obtain a level of randomness that is acceptable to them. Second, users could do sensitivity analysis by varying decision variables such as the number of skilled and non-skilled workers. This allows users to compare total costs of different scenarios and to change values of decision variables in order to obtain their design outputs. SmartInv has the following unique features: adaptability, practicality, applicability, and user-friendliness. Adaptability: it allows decision makers to vary different distributions for different input variables, such as daily inventory level, workers' turnover rate, absentee rate, and counting speed. Practicality: SmartInv takes into account of uncertainties in daily inventory levels, also differentiating between weekdays and weekend situations, and it factors in uncertainties of workers' productivity level, turnover rates, and so on. Applicability: it allows users to do sensitivity analysis to obtain design outputs. User-friendliness: an easy-to-use web interface that allows users to enter customized input variables.
So that's all for our product demonstration video. SmartInv is an effective and efficient tool that can revolutionize your inventory counting process. If you're interested in our products, contact us today at smartinv131@gmail.com. Thank you.